in my second presentation, actually the subject is linked one another. It's still about the digital transformation, but now it's about the supply chains. So it's a work with my supervisor from Galatasaray University from Istanbul. So in my presentation also, I will give a brief introduction about the resilient supply chain, the digital transformation, and the nowadays situation about this transformation. And also I will give the details of the steps of the proposed methodology, and I will continue with the case study as well. And I will finalize my presentation with the conclusion and the perspectives. So similar to the first one, we are still talking about this digitalization, but we're talking about the supply chains. Now we're all aware of today's situation. We're in a pandemic actually, and due to this pandemic situation, the resilience of the supply chain gain more and more importance to be able to act resilient to the changing environment. Today, we know that supply chains are more globally interdependent than ever before. So one disruption in the one part of the world can trigger another impact in every part of the supply chain. So from producers to the distributors, the flexibility, the agility, and also the resilience has a critical importance at this point. So also in order to gain a competitive advantage as a company for the future strategies, obtaining a resilient supply chain is also very essential. So at this point in the resilient supply chains, our paper mainly focus on the use of autonomous robots. And why we use autonomous robots today, they are getting actually more cost efficient, and due to the technological improvements. They also provide mobility, flexibility, and agility, mostly in the warehouses. So without using human forces, the autonomous robots can actually react faster to the changing environment just from a remote control actually. They are based on artificial intelligence logarithms. So by changing the coding from a remote control, they can they can adapt fastly to the changing environment. So based on these benefits, we wanted to focus on this topic, and we wanted to focus on selection of the appropriate robots for the warehouses. And we're talking about resilient supply chain. When we look to the definition of the resilient supply chain, we can say that it refers to the ability to be prepared for unexpected risk events, responding and recovering quickly to the potential disruptions. So it's very critical in our era because we are facing some unexpected situations, and when the supply chains are globally working environments, so a small effect can make a huge impact on other supply chains. So accordingly, we wanted to focus on this subject, and we wanted to create a multi-criteria decision-making environment as the previous one to be able to assess the technologies. Because to be able to achieve a successful automation throughout the supply chain, the technologies has a crucial importance. So selecting the most suitable technology among different alternatives is very vital process, because the incorrect or the unnecessary investment in technology can cause damage to their business. So we have proposed a multi-criteria decision-making approach. At this approach, we have used the Vicar methodology. It's a multi-criteria decision-making method. It's a distance-based method, and it gives the possibility to assess various alternatives with beneficial and the conflicting criteria. At the first part, we have also used group decision-making, and also we have used a literature review to be able to create assessment criteria and the alternatives. So as the previous one, the group decision-making method is also holds a critical role because it provides an objective decision-making environment and diversity of views. And in this part, we have applied a case study. At this paper, this study actually more primitive than the previous one. We have a small company, a logistic company from Turkey, but they wanted to investigate for their future strategies. Actually, they wanted to see how the cost of the new technology. They wanted to trace a roadmap for their future technology adaptation. Actually, and accordingly, as a first step, we have start with defining the group for decision, and we have detected the alternatives, and we have construct the decision-making group. So we have worked with the ABC company. There's a logistic company from, they have 2 managers and 3 IT department workers. So we have worked with them. In this case, 2 different linguistic scales are suggested for managers. As you can see here, the linguistic scale with the higher granularity is proposed to IT managers because they are more deep, they have more deeper knowledge about these technologies. And for the managers, a less granulated linguistic scale is proposed to the managers. So they wanted to assess the alternatives. So we have detected together 7 different alternatives, as you can see here. They are all autonomous robots that can suitable work in warehouses. And to be able to assess them, we have deducted 5 different criteria. At this case, we have 1 level of criteria. These are cost, the velocity, the load capacity, operating time, and the functionality. So according to these criteria, we are going to, the decision-making group will evaluate the alternatives. So we have obtained the criteria, the dimensions, we have the linguistic scales. First of all, the criteria weighting is the first step. As you can see, 5 decision makers evaluated each dimension with their linguistic scales. And accordingly, with the 2-tuple linguistic model, we have aggregated their linguistic scales. But first of all, there were 2 different levels of multigranularity. We first unified them under the highest granular linguistic set. Afterward, we have aggregated them with the weighted aggregation operator from 2-tuple linguistic model. Accordingly, we have obtained the weights of the assessment criteria. The second part is the assessment of the alternatives. This stage also, 5 different decision makers assess the alternatives, and we also aggregate their linguistic assessments as well. As you can see here, here is the ultimate aggregated decision matrix for the Vicar methodology. Each linguistic assessment from 5 different decision makers aggregated, and the ultimate decision-making assessment matrix is obtained. So according to these metrics and the obtained criteria, we are going to apply the Vicar methodology. At the end of the Vicar methodology, we obtain us S, R, and Q values. These values are evaluated together to be able to obtain the most most suitable criteria, most suitable alternative. So as you can see here, the 6th alternative, the 6th alternative, which is ranked the first one with the S, R, and Q values, is the most suitable one for the company. I'm sorry for the picture, it was the longer alternative. So accordingly, at this stage, we cannot use a comparative analysis or a sensitivity analysis to test the robustness of our proposed methodology. But for the future studies, we plan to compare this Vicar methodology with a similar a distance-based multi-criteria decision-making methods. And also we wanted to increase the criteria and dimensions to be able to create more in-depth assessments, more in-depth investigation of alternatives. And in our paper, we wanted to work on the resilient supply chain since it's a very important subject when we are facing this pandemic situation nowadays. And the technology selection problem is critical for us because the digital transformation is everywhere in every sector. The supply chain is actually the key components of every sector. Every sector has a value chain and a supply chain. So resilience of these chains are very critical for the future strategies for the companies and also for the stakeholders as well. And accordingly, we have applied this methodology with a case study, and we have shown that the sixth alternative is the most suitable one for them. So thank you for listening. If you have further questions, you can